Hey friends, welcome to Science Gallery. Today I am here with a new topic, short circuit. Have you ever heard about short circuit? A short circuit is taken as a problem in an electric circuit where two or more wires that are not supposed to come in contact touch each other. A short circuit can result in a very high current flowing through the circuit, and this high current can destroy the components of the circuit and break out the fire. As the name suggests, short circuit is a condition where electricity completes its circuit through a shorter distance. Let me tell you or explain you with the help of an experiment. In this experiment, I have made a circuit. As you can see, a battery is over here and battery's positive, negative terminals are connected to bulb and switch. So this is the open circuit where light is, the bulb is not glowing and it is not working. That means it is open circuit. Now it will be closed. Now in closed circuit what happens? The current flows. Okay, and in open circuit what happens? The light or current does not flow inside the circuit. Now what I have to do in the next step, this is the whole circuit. Now I have to take another wire and this wire has to be connected in the middle of this circuit from the positive to the negative terminals of the battery. Now what you can see, that the circuit has been shortened. Now what you can see that two circuits are here. One circuit is bigger one and another circuit is smaller one, which terminates in the middle of the bigger circuit. Okay, now let's see what is the result of bisecting this bigger one circuit. What happens? Let's switch on this switch. What happens? The bulb is not at all glowing. That means the current is not passing through this bigger one circuit. Now see what happens if I detach this another piece of wire once again from this bigger circuit. See what happens? Again the bulb has started to glow. Now see, if I connect this additional wire, the bulb stopped to glow. And if I again detach it from there, then what happens? The bulb again starts to glow. Then what does it mean? That if this wire is connected to bigger one circuit, the circuit becomes smaller and the current starts to flow in this smaller circuit and it does not go through this route. That is why the bulb stopped to glow. And whenever I again detach this additional piece of wire, the bulb again starts to glow. So this is known as short circuit. Now see again. If short circuit is not there, if not any additional wire is connected to it, bulb keeps on glowing, and whenever the additional piece of wire is connected, the circuit becomes short and the current starts to flow through this small circuit and the bulb does not glow at all. But generally, we imply the meaning of short circuit by a problem, fault or damage caused by electricity. So why and how does this damage happen? Let's discuss. A short circuit occurs when positive and negative terminals of battery are connected with a low resistance in a conductor. With a low resistance, a high current will flow. Why does it happen that in a low resistance, high current flows? As you already know that resistance is equal to V upon I. R is equal to V upon I. What is R over here? R is resistance, while V is what? Potential difference. Which is divided by current I. So you can see by yourself that resistance and current are inversely proportional. R is inversely proportional to I, current. As you already know that this is the sign of proportional to, so R is inversely proportional because it is written down as a denominator. So this is inversely proportional. That means when R increases, then I decreases, and if R decreases, then I will increase. Let me explain it to you with the help of a diagram. This is the diagram of electric circuit. As you already know that in an electric circuit, a battery is there and the current starts from the positive terminal of the battery. Actually, it starts from negative terminal to positive, but conventionally we show it like that, from positive to negative. So current starts from here, it keeps on moving, and after moving further it crosses through the low resistance, and then it is measured in ammeter and again to minus terminal. As now itself you have learnt that current is inversely proportional to resistance. That means lesser the resistance, higher the current, or higher the resistance, lesser the current, it will flow through it. So in this circuit, what we have applied? We have applied a lesser amount of resistance. So what will happen? And due to this low resistance, higher amount of current will be flown through this circuit, and actually this is not very much able to carry this huge amount of current. So what will finally happen? Finally, this whole circuit will get damaged due to the high amount of current. Here again and again we are pointing the same thing, that due to high current, explosion will occur. So is there any connection between high current and explosion? Let me tell you. Actually, high current and temperature are proportional to each other. Whenever current increases, the temperature also increases, and current decreases, temperature decreases. So due to high current which is flowing through a circuit, and the circuit which is not able to carry it properly, what will happen? The temperature of the circuit will increase so much, which results in explosion. So these short circuits are actually electrical accidents which can cause serious damage. Now the question arises, when and where does this damage or explosion occurs? Because in our previous experiment showing short circuit, there was not any damage. So why it is always connected to damage or explosion? Let me tell you. In our previous experiment, we had made a circuit in which a battery was there and a bulb was connected to this circuit with a key. So what was happening? Initially, the current was flowing from this circuit across this circuit, and the bulb started to glow. But simultaneously, at the same time, we took another wire and attached it from positive terminal to the negative terminal of the battery, disturbing the initial circuit. One thing is very important to notice here, that electricity has the tendency to complete its circuit through the shortest circuit or distance. So whenever we attach this smallest circuit within this bigger circuit, what will happen? The electricity will run through this smaller circuit only and will try to reach from positive to negative terminal as soon as possible. So finally what will happen? It will stop flowing through the bigger circuit, and the bulb which is in the bigger circuit, it will stop glowing. Or in other words, you can say that electricity or current is very lazy in nature. It wants to complete its circuit by a shortest route. Electricity does not choose the longer route to reach negative terminal if it already has another option for reaching the negative terminal, and which is comparatively shorter. Suppose you are standing here and you have to reach that destination. You have got a number of routes or number of choices to reach there. One choice is that, another route is that third root is here and fourth root is directly here from there. So which is the shortest route? This is the shortest route. So which route you will choose to reach there? You will definitely choose the shortest route to reach your destination. Same thing happens in case of electricity. Electricity means what? The flow of electron from positive to negative terminal. Finally, the electrons have to reach negative terminal. So if they have been given different choices, that one route is like that, it starts from positive terminal and it is a long route, and another route it also has been given, that is the shortest route starts from here and ends very early. So it will like to choose this path, this shorter path. There is not any problem in choosing shorter path, but the problem arises when this shorter path is not able to carry the load or heavy load of current which is produced by the current source. Due to this heavy load of electricity flowing through this smaller circuit, the heat of this smaller circuit increases by leaps and bounds, which results in explosion. In that experiment, we knew very well that the wire which we are attaching later in initial longer circuit is capable enough to carrying the load of electricity produced by the battery, or the battery which is producing electricity is not capable enough to emit a higher amount of electricity. So in both these cases, no damage will be occurred. In the circuit where the large source of electricity is connected, a number of other components are also connected with appreciable resistance, which share the heavy load of this electricity and don't cause any harm. And the current keeps on running in this large circuit very smoothly. But at the same time, if any other conductor medium is connected joining its positive and negative terminals, the current will adopt this smaller route, leaving its larger circuit, and will start flowing through this smaller circuit conducting material, which is not able to tolerate the excessive amount of current which is to be tolerated by this larger circuit, and the heat of this smaller circuit or conducting material increases terribly, and which causes a serious explosion, which is known as short circuit. So friends, in this chapter we got acquainted with short circuit and the harms and dangers caused by it. In our next video, we will learn how to reduce the risk of short circuit and about the safety measures also. Till then, be aware, be safe, take care.